So we exited out of that IPython. We're gonna source activate back to our source activate back to Python 3 if you changed environments. And I'm gonna type IPython. And so we're gonna cover a few loop things here. So we're gonna cover a few little tricks. So one is this enumerate function. So you have this ability to enumerate over a list, which will give you the keys and values. So if we do for I, V, and I stands for index and V stands for value, but you could call these things whatever you want. And then we print, and you see you get the index and the value next to each other. So it's kind of handy. We saw this zip function before with dictionaries. You can use zip to combine two lists together and print out the values together. I won't copy and paste this example, but then this is using this formatter that we saw before. Another way to use formats. Also, as we saw before, we have this zip function that can be used with dictionaries. So we can zip these two lists together and then make a dictionary out of them, and that will give us a dictionary that has the key value pairs from list 1 and list 2. We can reverse a list using this function reversed, and so this is just using that range function that we saw, but in this case we're giving a start, a stop, and an increment, and then we're reversing it. So we're gonna, when we print it out, we're gonna get that list that list in reverse. We can copy this one. So we're gonna make a list called basket, which has all these fruits in it, but you can see there's some duplicates. So one way we can take a list that has duplicates and just get the unique items is to turn it into a set. And then the set, you can use this function sorted, or you can turn it into a list, and it will just print out the sorted list of unique things. Again, I think this one needs to be changed to items, but you can get all the items of a dictionary. And then we have this nan. If we import the math module, I'll just highlight this. I won't run it over here. But if we import the math module, and then we just have a list that has some floating point values, and then these nan. So we're taking the string that's nan and converting it to a float, and that has a special meaning that will make it a nan. And then we're going to make another list it's an empty list, and then we're going to go through a loop for each value in this list raw data. We're going to, if it is not a nan, so that math has this function is nan. So if not is nan, that means it's just a number. It's not a nan. We'll take this list and append the value to that list. And so when this loop is done executing, we'll have created a new list that only has the numbers in it and not the nans. So we also saw before list comprehensions, and these are really powerful, and we saw a very similar example. So if we had done a traditional loop, we'd make an empty list and then do a for loop, and for each thing in that list we would do something, we would append it to this new list. Whereas with a list comprehension, we can just simply say x squared for x in range 10, and it's going to generate a list that's the exact same output that we would have gotten here, but much more simply. There's also this this lambda thing. So there's two things going on here. Let me see if hopefully this works. Yeah. So this map function basically maps x to x squared for these values, and lambda is a function that says, okay, x is going to be a variable. So lambda x means x is going to be a variable, and here's what I'm going to do with it. I'm going to generate this expression x squared, and these are the values that I'm going to do it with. So these are all equivalent output, just different ways to do it. In fact, we could even do a two-dimensional list comprehension, which would generate a set of tuples instead of a list of tuples instead of a list of integers. And this is how we would do it with a traditional loop. I'm going to skip over this for time. Are there any questions before we move on? Okay, so what I want to do now is, so at the beginning of the course, I had you guys take a survey, and I used Google Forms this year for that. But in the first year I taught this course, I had everybody run this program, and they would enter their responses, and then give the send me the output of their responses. So what I want to do is kind of walk through this program, and we can kind of see how it works. So what we're going to do is, starting up at this comment here, copy down to the end of the script, which should be down here, and then you can type Command C, copy that. We're going to exit out of the IPython, so now we're just in our environment, and we can go to our lessons folder. So that's SIO209. From our home folder, it would be SIO209/lessons. And we're going to cat to survey SIO209.py. Let me make this a little bigger. And hit enter, and now we're going to get a prompt, right? And so we copied that text already, so we can hit Command V, and it's going to spit out all that text, and then I'm going to hit enter one more time, just because I'd like my script to end with a new line character, and then hit Control C, and we want to check that script looks right, so we're going to type less survey SIO209.py. And we can view the survey here. If you want to see your nice color, and you could type Atom or Sublime. If you use that shortcut, remember you have to have the shortcut or the alias. But if you did, then it'll open up Atom, and you'll see it knows that this is Python, so it'll color it based on that. But we don't need to worry about that right now, because the way that I entered the markdown format here, we're getting Python coloring also. Everybody able to get that script on their own machine? Okay. So what we're going to do is we're going to run the code and see what it does first, just as if we're the user. So we're going to type Python survey SIO209.py. This is going to use the version of Python that's in our path, which is the Python 3 environments version, which is a Python 3 edition of Python. So it's going to give us this prompt, and then it says, please answer the questions. And this should be familiar because this is kind of what you did in some of your homeworks. So you can enter your name, and then you can just answer the questions. Just put in whatever you feel like. So it doesn't matter what you enter, but it's giving you these instructions, so it helps you to answer this. And then it says, thank you for completing the survey. Your answers have been stored in the file answers underscore whatever you put for your first and last name. So then we can look at that file, or we can type ls_lrt, or if you have the shortcut tail with 2 L's, it's going to give you the last 10 files sorted by age, and so the last one is going to be that file we just made. So we can look at that, and this is the output that it generates. So what did this do? So this is the script itself, and we can walk through what it's doing. So first thing it's going to do is going to print this header message, and so this is something that kind of just tells you what the script is about. As you do a little bit more Python programming, there's one called Click, which gives you some help documentation that you can specify. That's maybe a little more advanced, but and then we're going to define these functions. So we have this function called get free text, which using a prompt, if you specify a prompt, it will ask for input from that prompt. So it uses this input function and asks the user for this answer, and then it returns the answer. So this function is, every time we're asking for input, we're using this get free text prompt. But sometimes we don't want actually free text, we want a number, right? We asked for 0, 1, 2, or 3. So if the user didn't enter 0, 1, 2, or 3, it's going to if the user does enter 0, 1, 2, or 3, it'll break out of this loop and return the answer. But if they don't, it'll say you must enter a number from 0 to 3. So let's try this out, because as we see below, whenever we're asking for a score, we're saying get score. Similarly, get computer has to be Mac, Linux, or Windows, and get yes, no has to be Y or N. So this one's kind of interesting. So I walked you through the loop here for get score. It has to be a 0, 1, 2, or 3, and the answer for computer has to be Mac, Linux, or Windows. So if it's not in that while answer is not in this. So first it says answer is blank, and so while answer is not in one of these, then ask what is your operating system. And if you don't enter one of these, it'll keep going through this while loop. This yes no is similar. It says first when I use this function, it's going to say, okay, answer is set to an empty string. So while answer is not in y or n, keep asking. So initially it will not be in this list because I initialized it to an empty string. So it's going to prompt you for an answer. And then it's going to take the first character of the answer. So answer bracket 0. So answer is a string. So it's going to give you the first character, and it's going to convert that to uppercase and then store that as the answer. And then it's going to go back to this loop and say, is that first character uppercased, a y or an n? If it is, it will exit out of the loop and return answer. And if not, it will keep going through this loop. And so the rest of the program is just using those functions. So it's going to say, what's the first name? And it's going to use this get free text function. And then it's going to say, and then for last name, it's going to say, same thing, get free text, and then use this prompt, and it's going to store last name. And then for the computer, it's going to it's a yes or no question, so it's going to use this get yes or no function that I made. And for computer operating system, it's going to use this get computer function, which I sort of hard-coded that prompt into that function because I'm only using that question once. So I know what the prompt should be. And then it prints this. It prints these instructions saying enter. After we do these ones, it's going to say now for these ones I need you to answer 0, 1, 2, or 3 based on none, some, moderate, or experience. And then it's going to store. It's going to prompt and ask these questions and store those values. Then it's going to make a dictionary of the values and sort by the keys. And then it's going to make an out file using the first and last name .csv. It's going to open that to write, and then for each key in that dictionary, it's going to write the key and the answers for that key, and then it's going to close that. Now I didn't have to use a dictionary, but I chose to, and then it's just going to print this command, and it's going to say, hey, your answers have been stored in this file, and here's the name. So if we go back and we run that code again, I think it'll make a little more sense. So first it's giving us this prompt here, and then all these functions are defined up at the top, but they aren't actually used until we call them. So these are all defined at the beginning, and that's good form. You have to define the function before it can be used. And then we're going to say, so what's happening here, where we are right now in the code, is we're stuck right here. We're at first name equals get free text and then this prompt. And so get free text is going to say, oh, I know that function. I just saw it entered up here. It's going to go run this function using this prompt. And so now it's sitting right here. It's saying, I'm waiting for your input for the answer. So you can just say enter the first name, and now we're here at last name. It's asking for last name, and so it's running this function again. And now it's saying, do you have a laptop? Yes or no. So it's giving me a prompt, but let's say I say maybe. So what happened here? So it said it's a yes/no question. So it's saying, do you have your own laptop? And that's a yes/no question, so it's using this function get yes no. Initially, the answer is an empty string, so it's going to ask. So it's going to say, well, okay, while answer is not in yes no, so that's not currently it's not a y or n. So it's going to prompt for an answer, and it's going to convert the first character to an uppercase, and that's going to be the value stored as answer. So what it's doing here is currently answer is capital M, right? So if I type I don't know, but if I type you know it, that's gonna count as yes based on the way I wrote my code. So maybe that's not such a good thing, but I decided that if whatever they typed is that allows someone to type yes or no instead of y or n, and it'll still work. Okay, so which operating system do you run? I can type I'm running Sun, or I'm running.
Wait, really quick, just to clarify.
Yeah.
So when you said I don't know, you have an end in there, but it's because it's not at the beginning of
Correct.
the word. Okay.
So this answer bracket 0. Remember that strings are kind of like lists in that
Gotcha. So it has to be the first letter.
the first letter can be that gets the first letter. So it's taking the first letter, making it uppercase, and then saying that's the answer. So now this which operating system does your computer run? This is this function get computer. It has to be Mac, Linux, or Windows. If I type Mac, it doesn't work. If I type Linux, it doesn't work. It has to be exactly what's in this list. I didn't make any concessions for someone typing it wrong. So if I type Mac, that doesn't work. I have to type Mac. You can see it just keeps giving me a prompt. Okay, now I typed a valid response. Now it lets me go. Now same thing for here. The answer has to be in this. So if I type 0, it says you must select a number from 1 to 3. If I do 5, so it's going to keep asking me until I give a number from 1 to 3. If I do space 1, it won't work. I could have added a strip thing to that, a strip function, but I didn't. So I'm going to enter just a 1, and now I can continue to enter these following the instructions, and then at the end it's going to say once I've entered all these instructions, it's going to make this dictionary and sort it and then spit out the output, and then it's going to tell me, thank you for completing the survey, your answers have been stored in this file here. And so if I look now, I can see that it's created this CSV file with all my answers. Any questions on that? Yep.
In function of the gas code, you just type in while true. If you just delete while true, is it still working?
For get score,
Yeah.
if I just type 1 or 2,
No, I mean, why do you just add while true the first line?
I don't which
The function of the gas code.
Yep.
And
Yep.
while true.
yes. Why did I add while true?
Yeah.
Yes, good question. So while true is it's kind of like a workaround to say this loop will never exit until it sees the word break. So if I didn't have this word break in here, if it was just while true and then some commands, it would just keep going forever, like literally forever, until you hit Command C on your terminal to exit out of the program.
So if you just delete and you keep the if, the loop of if, it's still working.
So the only way that this will break out of this while true function is if this statement is true. If answer is in this list. If I don't enter 0, 1, 2, or 3, it will never break out of this loop because it will never. This statement will never be true, and so break will never be executed. So break is what takes us out of this while loop. That's a good question. I didn't explain that before. So if it's not in this list, then it's going to say, and it's going to get to this else part. The else is in response to the if. So if this, if not else, print you must enter a number from 0 to 3, and then it's going to go back. And that, so because the while loop is saying while some expression, and then is that, and if the expression is true, the while loop will execute. So the word true is an expression that is always true, right? By definition. So saying while true is just a sneaky way of saying do this loop always. Unless, and the only exception is if it encounters this break command. So it's a little.
But without it and without the break sentence, then still works, right?
So, sorry.
Without the while true sentence and the break sentence, then this whole function will still work.
I think so. Yeah, I think you could just say. Mm-hmm. Yeah, I could have done it. I could have done it in this syntax. The example is sort of it's sort of a different way to do it. Like yeah. Are while loops slower than for loops? I don't know. Yeah. What's that? Yeah. Yeah. Yeah, I don't know. I don't know about the performance of the different loops.
It's like how do you know what key? Because you could essentially do the same with either. Choose, right?
Yeah, that's a good question.
I find sometimes if I don't know how long something is, then mine is good. Or you can know what I'm iterating over in force.
Mm-hmm.
With the lab is nice. I guess you could do it.
Mm-hmm. I mean, these are all going to be, any of these different alternatives are going to be very, very fast, right, for this particular program. It's when you start getting into bigger data structures. And again, I know I keep saying this, but once we start using pandas, it has its own a lot of it's built into how it handles the data underneath. So the implementation is kind of handled for you. And another point to make is that Python is not known to be the fastest programming language. People use it because it's intuitive and easy to read and write code, and for most purposes it is fast enough. But if what you're doing is very computationally intensive, it could be the case that you'd want to implement it directly in C, for example, or Perl. Yeah.